So let me, yeah, good morning to all again. So let me share the file. Right. So I gave the, few of them like no co-host permission, you can add them. Right. So today, what we are going to do, I mean, this is unit 2 actually. You know that we have already started the mechanics. First unit is over. So we're going to, start the second unit. Okay. So the second unit already we started. We completed the laws of motion, right? And today we are going to focus very, very interesting stuff, that is variable mass. Variable mass, rocket. How does rocket works? What are the functions of the rocket? How rocket goes from the, how the, different orbits, how energy get that. So we are going to work on that. Okay. So see here, are you able to see better? What
Yes,
is
sir.
this? What is this?
Rocket, sir.
How does it go that? How it works? How it is going like that? What it
Action.
require? ఏమి కావాలి దానికి? What does it read? What does it need?
Fire, sir.
Huh?
Petroleum.
Really? Can we keep the petroleum inside? No.
Hydrogen gas.
Hydrogen gas.
Hydrogen gas.
Liquid nitrogen, lot of gases. Yes, that's true. So we have to fill the some kind of energy gases. Okay.
Gas.
So how does it go further? Like, it goes like a orbit, right? 1,000 kilometers away. How it goes? I want you to design this. How can you design? I want you to be scientist in that. ISRO.
So,
You have a passion. Really, do you want a passion to be there? One of my classmates is there. I can ask you to, you can visit her. Really, see how, like, if you feel that you can dream that you are doing that job, how do you feel it? Really wonderful, right?
Yes, sir.
ఒక్కసారి మనము అందులో చేసినాం అంటే లైఫ్ చాలుగా అందులో పనిచేస్తున్నాం అంటే మనం వీఆర్ గివింగ్ ద అవర్ సర్వీసెస్ టు ది కంట్రీ ప్రౌడ్గా ఫీల్ అయ్యేది ఒక్కటి చేస్తే చాలు నాన్న. కంట్రీ కనీసం మీ పేరెంట్స్ ప్రౌడ్గా ఫీల్ అయ్యేది చేయండి. కంట్రీ తర్వాత సంగతి. యూ హ్యావ్ టు డూ ఇట్. అట్లీస్ట్ మేక్ యువర్ పేరెంట్స్ హ్యాపీ. దెన్ యూ కెన్ మేక్ అస్ హ్యాపీ. దెన్ యూ మేక్ యువర్ సెల్ఫ్ హ్యాపీ. దెన్ మేక్ ద కంట్రీ హ్యాపీ. Sorry. Okay.
Okay, sir.
So did you understand?
Yes, sir.
Thank you. Thank you. So now, what is the title I am keeping here? Variable mass. What is that? Why I am saying variable mass?
Different type mass.
Why I am using the variable mass word here? That means, did you understand what is the meaning of variable?
Different, sir.
Chepnana.
Different.
Variable ante different ante changeable, right?
Changeable.
Correct. Ante mass is changing. Why its mass is changing? I am keeping an example here, rocket. Because the mass is losing here, right? What mass is losing? The fuel is losing, right? The fuel is going out, right? The entire mass of the system is losing, right? Gradually. Did you understand? It's like a Newton third law going on here, right?
Action is equal to mass of
Action.
reaction.
So it's going away because it's pulling out, like the gas is going in opposite direction. So here mass is changing. Mass of the rocket system gradually decreasing and is going forward direction. So that is the reason we are saying variable mass system. The best example we give is rocket. So rocket motion, this is also for like long answer question. Sometimes they'll ask 4 marks. This is actually long answer question, 12 marks question. So far we have considered the motion of the system. Here I am going to talk about, motion of the system. So this is the digital part. You can see here. I can write whatever, like, board. So when I write here, you can see on the slides only. So which is very useful for me for online classes, right? And now you can see the this system is, okay. What happened? Oh, sorry. Okay, what's going on? Right. So here, right. So I can see here, what is the what we are thinking is, whatever we discussed before, mass is constant. M is, we always say constant, right?
Uh,
M is constant. Mass does not change basically. But now
okay.
the system we are considering, the mass is changing. We are considering the motion of the system like a rocket.
Okay.
Rocket. The mass is changing. But previously we didn't talk about this, right? So mass is always constant. Previously we used to discuss mass is constant for any mass. Suppose if I ask to run, your mass is constant. But the rocket system, the rocket mass always going losing because it's losing the fuel, right? So let us consider the system where the mass is variable. What we are considering is where the mass is losing. Write down the steps. Okay. The best example is rocket system. The best example is rocket. So the title should be variable mass system. So this is the title, you can write it. So let us consider the system where the mass is variable. Example is rocket system is the best example. Now in the rocket system,
It is explained like
what it does, tell me? It expel the gas at a high velocity. అంటే ఈ గ్యాస్ అనేది
equal velocity.
బాగా మనకి వెనక సైడ్ వస్తుంది కదా, బాగా వెలాసిటీ. ఇట్ ఎక్స్పెల్ ద గ్యాస్ ఎట్ హై వెలాసిటీ సిన్స్ ద రాకెట్ అప్లైస్ ద ఫోర్స్ ఆన్ ద గ్యాస్. ద గ్యాస్ ఆల్సో అప్లై ఫోర్స్ ఆన్ ద రాకెట్. దిస్ ఇస్ లైక్ యాక్షన్ రియాక్షన్ ఫోర్స్, రైట్? So action and reaction force. So in the rocket system, what is going on? The gas is moving with a high velocity, and the rocket, why? Because rocket is applying a force on the gas to go, it expel backside, and the same gas also apply a force on the rocket. This is action reaction forces.
Newton's laws are
Newton third law, right? Correct. So then, so what we are here, we give the importance of the rocket motion. We don't care about the gas which we are losing. మనము గ్యాస్ మీద ఫోకస్ చేయము. ఎంత గ్యాస్ అనేది ఎంత కావాలో అంత fill that gas. But here the main focus is what is the motion of the rocket. Rocket ఎలా వెళ్తుంది? Motion of rocket. So this is what main focus of our concept today. So we have to try to answer this question. Hope we can able to answer by the end of the class. So here what we are trying to assume here, what we are trying to say, at a time t, అంటే ఒక time, just we are considering at a time t, the mass of the system is saying that, what we are saying is m. Mass of the system is how much? The entire rocket, the mass of the system is m, moving with a velocity v. Is it clear? So mass we are assuming m and it's moving with a velocity v.
Simple.
Right? At later time, t plus dt. I mean, we are talking about suppose 0 time. This is 20 seconds. You can think about it. This is 0 time t. This is after some time, which we are assuming is t plus dt. Both mass and velocity of the system have changed. అర్థం కాని ఏమైనా ఉందా ఇక్కడ? ఫస్ట్ మాస్ ఎం అనుకుంటున్నాం, వెలాసిటీ వి. బట్ కొంత టైం తర్వాత ఇక్కడ ఏమవుతుంది, మాస్ లూజ్ అవుతుంది, అది బాగా ఫాస్ట్ గా పోతుంది కాబట్టి ఇట్ లూజెస్ సమ్ మాస్ ఇన్ టర్మ్స్ ఆఫ్ ద ఫ్యూయల్, రైట్? And the velocity also changing gradually because as it loses the gas and it also increases its velocity and it enter into the orbits and turn around the earth. It gives the communication detail, rain, weather forecasting, a lot of information it gives. Satellites, right? So why we use the satellites? Satellites can help to give the information around the earth. Weather conditions ఎలా ఉన్నాయి, కమ్యూనికేషన్ ఎలా పనిచేస్తుంది, నెట్వర్క్ ఎలా పనిచేస్తుంది, మనకు ఫోన్ కనెక్షన్ ఎందుకు పనిచేయట్లేదు, ఇవన్నీ కూడా ఇట్స్ ఎ జాబ్ ఆఫ్ ది సాటిలైట్స్, రైట్? So now we understand derivation t m. After some time t, mass m, velocity both are changing. According to Newton's second law, we know that. According to Newton's second law, what we know, beta? We know this equation. Force definition. Force is rate of change of momentum. How we define the force? Force is a rate of change of
Velocity.
momentum, linear momentum. అంటే లీనియర్ మూమెంటం అంటే ఏంటి బేటా? ఇట్స్ మాస్ ఇంటూ వెలాసిటీ. హౌ దిస్ మూమెంటం ఈస్ చేంజింగ్ విత్ రెస్పెక్ట్ టు టైమ్, దాట్ ఇండికేట్స్ సెకండ్.
The rate of velocity changing.
Right. It's a rate of change of linear momentum. It's a rate of change of linear momentum is the force definition, which is equal to this Newton's second law. So as you all know that, here I am defining the initial momentum of the initial momentum. Note down this initial momentum of the system. అంటే రాకెట్ సిస్టమ్ యొక్క మూమెంటం ఎంత? m into v. లాంగ్ ఆన్సర్ బేటా, LAQ లాంగ్ ఆన్సర్ 12 marks. సో ఇనిషియల్ మూమెంటం ఎంత తీసుకున్నాం? what is the initial momentum? Mass into velocity. That's good. Final momentum, what I'm going to take here, as I mentioned it, finally what is going on? Mass is changing, velocity also changing. So I have to write it m plus dm, v plus dv. ఎందుకంటే మాస్ కాన్స్టెంట్ కాదు ఇక్కడ, సో మాస్ ఈజ్ వేరియబుల్. సో m plus dm, v plus dv. Okay, plus, what is plus, sir? Why we are doing this? I'm going to tell that. U minus dm. U minus dm. What is this, sir? We need to understand. I'm going to coming back to that. Okay. What is the dm I mentioned here? U is the velocity of ejected mass of gas. అంటే ఏదైతే గ్యాస్ వెనకకి వెళ్ళిపోతుందో ఆ గ్యాస్ ఇంత వెలాసిటీతో బ్యాక్ వెళ్ళిపోతుంది, గ్యాస్ వెలాసిటీ. అండ్ dm is actually the mass of the ejected gas. Why? Because losing, we are keeping the negative term. నెగిటివ్ ఎందుకు పెట్టారు సార్ అంటే, బికాస్ వీఆర్ లూజింగ్ ఇట్, ఇట్స్ నాట్ ఇంక్రీజింగ్, రైట్? లూజింగ్ కాబట్టి మైనస్ పెట్టా. సో ఈ టర్మ్ అంతా ఎలా వచ్చింది సార్ అంటే, ఈ టర్మ్ ఈజ్ రిలేటెడ్ టు ద క్వాంటిటీ దట్ వీఆర్ లూజింగ్. దిస్ ఈస్ ద మూమెంటమ్ విచ్ ఈస్ గోయింగ్ ఆపోజిట్ డైరెక్షన్, రైట్? This is the momentum of the gas which we are losing it. This is the momentum which is there, and this is the momentum which we are losing. Losing means in terms of the opposite direction, it's going away in terms of gas. Is it clear, Nana? Any doubts, please? డియర్
No,
స్టూడెంట్స్,
no doubts, sir.
ఇక్కడ గుర్తుంచుకోవాల్సింది న్యూటన్ సెకండ్ల ఇనిషియల్ మూమెంటం, ఫైనల్ మూమెంటం. ఫైనల్ మూమెంటంలో ఇవి టర్మ్స్ ఎందుకు వస్తున్నాయి అంటే మాస్ వేరియబుల్ అవుతుంది కాబట్టి m ప్లస్ డిఎం, వెలాసిటీ కూడా v ప్లస్ డివి, రెండు కూడా చేంజ్ అవుతున్నాయి కాబట్టి మనం ఇది రాసాం. ఇది ఎందుకు రాసామంటే గ్యాస్ విచ్ ఇస్ గోయింగ్, we are
Ejected.
losing it from the rocket. So u is the velocity of the rocket. Dm is, we are keeping negative sign because it's losing, negative indicates. Negative indicate ejected mass. Ejected means losing it. U is the velocity of the ejected mass of the gas. Okay. So I am going for the next slide. If you are okay. So it is okay, right? Oh, great. Now I change something like, attractive for you to color so that I can, what color I can choose here is maybe I can go for the, no, it's red color, yeah. So now change in momentum, beta. Change in momentum. So we already know the PI, we already know the PF.
Here.
So how can I get dp? Final momentum minus
Initial momentum.
final momentum minus initial momentum. So final momentum, as I mentioned before, this is my final momentum. M plus dm, v plus dv plus u minus dm minus m.
Yeah.
Is it clear?
Yes.
Nana, is it clear? Hello, my dear students. Is it clear?
Yes, sir.
Yes, sir.
Okay, I'm just writing, but I just substituted what is PF and what is PI. Final minus initial. So then I multiplied M into V, MV. Note down everything. M into DV, MD. V into DM, V into DM, VDM. DM into DV, DM into DV. Minus UDM, minus UDM, minus MV. So plus MV, minus MV cancel. Plus MV, minus, and this is very negligible. This is negligible. Why negligible? Ante ikkada idi small quantity, but rendu kuda small quantities. Both are small quantities. We neglect these two terms. M is big, but DM is small. V is big, dV is small. If you multiply small into small, you get very small. Like this, 0.1 into 0.1. What are you going to get? 0.0001, which is still much more than this small, right? So we neglect this term. So what are the terms left, beta? What are the terms left? MdV plus VDM minus UDM minus UDM. Is it clear?
Yes, sir.
Yes, sir.
So up to here, I did not write it here, minus DM, UDM, it is there. Don't worry. And according to Newton's second law, F external force is equal to F external force. And that we could keep the external force here. F external force. Initially, manamu external force system kinda satellite launch aitunnappudu we keep some external force to push up. Okay. So F external force is equal to dP by dt, and dP, this is given. This is a dP. D by dt of dP is here, which we got it from here. Okay, that's good, sir. Then if I multiply here, I'm going to get here. M should come outside, M dV by dt. Okay, then from both of them, they have a dm common. In both of them, dm is there. So I'm taking the dm common. So dm by dt, dm by dt. Okay, so what I'm gonna do here, v మైనస్ u వస్తుంది ఇక్కడ. v ప్లస్ ఉంది మైనస్ u. v మైనస్ u వచ్చింది. ఓకే, ఇస్ ఇట్ క్లియర్?
Yes, sir.
Right. I'm going to keep up this. You can copy everything. So here I'm going to write this one is v real is equal to minus u minus v, which is the velocity of ejected mass. ఈ వెలాసిటీనే మనము ఎజెక్టెడ్ గ్యాస్ వెలాసిటీగా తీసుకుంటాం నెట్ గా. దిస్ ఇస్ యాక్చువల్లీ రిలేటివ్ velocity u minus v, and that is we are writing here v real, actual real velocity that is going away. So when I substitute that, I'm going to get this f external is equal to m dv by dt minus v real dm by dt. So any doubts here so far, Upender? Any doubts, Sai Nayak, Geeta?
No, sir.
Ajay ready? Sirisha, Divya? Anybody? No doubts?
No doubts,
No,
sir.
sir.
Oh, great. You guys are really great writers. మీరు మామూలుగా కాదు. మీకు అంత అర్థమవుతుందంటే డెఫినెట్గా ఐ హ్యావ్ టు అప్రిషియేట్ ఇట్. థ్యాంక్ యూ సో మచ్. వెరీ నైస్. కీప్ రాక్ అలా బాగా హార్డ్ వర్క్ చేస్తే డెఫినెట్గా మీరు యూ విల్ బి ద టాప్. సో ఐ ఆల్రెడీ ఎక్స్ప్లెయిన్ దిస్ హౌ వి గోట్ ఇట్. If external force is 0, means this is equal to 0. What I am going to get, tell me? When this is equal to 0, this is equal to this outlet. M dv by dt is equal to v real dm by dt. Right? So this is what we're going to get. Right? What we call this one is thrust of rocket. Thrust of, what is the meaning of thrust? Anybody want to say? Thrust and int beta. And how mass is changing with respect to time into velocity. That is actually how gas is expelling from the rocket. And opposite direction lo enta munduku rocket వెళ్ళిపోతుంది, వెనక గ్యాస్ వస్తుంది. సో థ్రస్ట్ అంటే ఇట్స్ కైండ్ ఆఫ్ లైక్ హౌ మచ్ ఫోర్స్ విచ్ ఇస్ కమింగ్ అవుట్ ఆఫ్ దట్. సో ఏ ఫోర్స్ తో వెనక్కి వెళ్తుంది. సో రాకెట్ కెన్ accelerate even no external force act on it, hence momentum is conserved. So up to here 12 marks. అంటే ఇక్కడ చూడండి. So what is going on here? So we proved this because external force 0 అయిపోయింది. When rocket launches from the ground, so we give the initial force, then we keep it at 0, right? We don't apply this force continuously, right? So rocket goes itself by expelling gases out. So rocket go forward direction and gas go reverse direction, and it makes the momentum is conserved. Pi is equal to pf. So rocket momentum is pf and gas momentum is pi. So both are equal. So momentum is conserved. Energy also conserved. So it's keep on going, and once it reaches the orbits of the Earth, whichever orbit the satellite you are looking to revolve, it just enter there and rotate like anything. Continuously rotate it around the Earth. So then it gives all the information that we are looking. Purpose lo esemo మొత్తం మనకి ఇక్కడ వస్తుంది. So any doubts beta? So far we completed this question. I'm going to show one example,
No, sir.
Important video now.
Send me in group, sir. Group lo send చేయండి సార్.
ఏది
ఈ క్వశ్చన్
మొత్తం యూట్యూబ్ అసలు మొత్తం ఈ స్లైడ్లు మొత్తం పోస్ట్ చేస్తా నేను. చాప్టర్ కాగానే మొత్తం స్లైడ్ పెట్టేస్తాను.
Okay.
టోటల్ మీకోసమే కదా ఏం చేసేది. ఇప్పుడు ఒకటి ఏం చేస్తున్నానంటే స్టాప్ షేరింగ్ పెట్టేసి ఐఎమ్ జస్ట్ no show. I want to show that YouTube video.
Yes.
I'm gonna share now. Practice it better.
Sir, this question 12 marks, sir. Sorry, answer
8 marks.
8 marks.
I'm gonna share now. Someone charted something. What is there? Definitely, sir. Thank you. Rakesh, I wanna share something. Okay, 3 rocket system. Can you able to see now?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
I'm gonna show first. This is multi rocket system. I'm showing how. See how it's going. The initial energy, yes. The initial energy, see, we have given. Then after that, we didn't give the initial energy. See how it's going on. Then after that, it loses some last part. Still it goes there. Why? It loses, see, the part which is not required. That helps only initially. See, really wonderful, right? I mean, if you can make this rocket, you will be like, exciting like anything. Why can't you make? Why can't you feel like that? Dream about it. Try to do something. Always at home. You do some experiment, science experiment, physics experiment. Come up with us. We will help you. And you can visit I can make you to visit IIT Hyderabad. I can make you to visit IITs. If you are really wonderful and passionate about research and doing some kind of activities, you come up, you come and meet me. I'll ask you to go. I'll ask you to. I'll send you in, IITs, NITs to meet uh, uh, faculty over there. See, this is the second stage. What is going on? See, first stage is over. First stage one is out. Second stage. This is about second stage, beta. Rocket. After it reaches certain height. See, in the second stage also it loses. That is the final stage. Third stage is there. Second stage it loses out that one. The third stage only one is there. It revolves around the orbits.
Wow.
So whichever the part is losing, actually, usually they try to, అది ఒక సీలో పడేటట్టు చేస్తారు. దాన్ని బయట ఎక్కడ పడితే అక్కడ పడకుండా ఆ చిన్న చిన్న పార్ట్ విచ్ ఈస్ లూజింగ్. సో నౌ ఇట్స్ గోయింగ్ టు ది see. I just want to show that finally how it goes. See, అంటే ఇదంతా ఎవరు చేస్తారు? మన ఇండియన్ సైంటిస్ట్లే బెటర్.
Scientist.
ISRO, sir, ISRO.
మరి ఇస్రోలో ఎవరు? నువ్వు నేనే కదా, మనలాంటి వాళ్ళే కదా.
Yes, sir. It is amazing.
Really
DRDO.
three stages are there. How the rocket works? First stage, second stage, third stage. Really wonderful. I mean, you can feel it. You can feel it, how it works. See? Did you feel something?
Yeah, sir.
What do you feel now? You want to do it?
Amazing.
Yes, sir.
Yes, lot of like very interesting stuff. Feeling like he's so proud. Really, why can't you part of that scientist team? You can do, right? Really wonderful. See this guy. How do you feel? See, yes, no, see how the parts you can see how they set up. Everything is important, beta. Wow. I mean, it's not easy job, guys. You have to work like anything. And ఒక passion తో కష్టపడాలా, ఒక dedication తో కష్టపడితేనే you reach this stage. And you when you get a job in there, and you feel so proud too that you are working for the country. See, so satellite making is not so. I mean, you can work actually. It's not so tough. See, you can see the earth completely. How does it looks when you go up top? You can see the view. The part which is losing what you see, it's falling in the sea.
Yes.
Did
చూస్తున్నా
you see that?
చూస్తున్నా
Yes, sir.
Usually we change the
Yeah,
direction.
yes, sir.
Yeah, we change the see how it's going faster, rotating our earth.
Yeah.
So the part which is very dangerous, which is losing. So అది ఏం చేస్తారంటే అది సీలో పడేటట్టు చేస్తారు, డైరెక్షన్ చేంజ్ చేస్తారు. So lot of interesting stuff, better. I mean, you can also see other one. Then I told you this is the next part of the stage. How that speed you cannot imagine. It's going like anything.
Oh,
So I guess I mean I think class is over. Third year student already joined. I think they are also watching now. Are you there,
Yes,
guys?
sir.
Yes.
Yes, sir.
Yes, sir.
Yeah, this
it's
is a rocket
amazing.
motion I am teaching for them. So rocket.
Sir, we
You
have another class, sir. Math class is there.
I know. Okay. First years, do you have a class?
Yes.
Yes, sir.
Yes, sir.
Oh, you have a okay. Yeah, you can leave better. I mean, I think this is over. But yeah, tomorrow no class, beta. Happy New Year, advance.
Same day, sir. Advance happy
Same
New
to you,
Year.
sir. Shiva, same to
Sir,
you.
same to you.
Thank you, Sana.
Thank you, sir. Same to you.
We'll see you on 2nd January.
Okay, sir.
Yes,
Okay,
sir.
sir.
New Year.
Advance
2020.
happy new year, sir.
Wonderful, sir.
Yeah, thank you, beta. Thank you. You see how there's all the team, NASA team.
Yes, sir. Super.
2015. They made models of rockets. Really wonderful. You can leave better. Thank you so much. Thank you. First years, please leave. So I'll start
Okay,
the
sir.
second.
Bye, sir.
Thank you, Nana. Thank you.
ఏమిటి తెలియదు కదా ఎలా ఉండిద్ది తెలిసింది ఏం కాదు వాచ్ కాబట్టి
Good morning to all again. Let me share the file. That. One second. And are we able to see? I did not make anyone to co-host so that I can just add them. Some people added. Okay. Shirisha, she joined today. Shailaj also joined. Swapna is there. I'll make you Swapna to host. Okay. Tammireddy Nagajyoti, I think Tammisetti Nagajyoti started to come. Before, I don't think she didn't come. But anyway. So yesterday, I think we were, stopped this. Let me. Today we'll, Okay. So yesterday we were lasers. Great welcome, guys. Yesterday, we were discussing about the lasers. So I mean, most of you understand what is a laser? Light. What is a laser? Can anyone tell that? Light amplification by stimulated emission of radiation, right? Is it? Did you remember that?
Yes, sir.
LA, light. A, amplification. S, by stimulated. Stimulated means you're giving energy. E, emission. R, emission, light amplification by stimulated emission of radiation. So in which we have studied three processes: absorption process, spontaneous emission process, stimulated process. Absorption process, simply, the material absorb the light and go into the higher energy level from E1 to E2. We also discuss a spontaneous emission. The photon, when the electron go from the lower energy level to the higher energy level, it comes to the ground state by emitting the photon. That is called spontaneous emission. There is one more emission called stimulated emission. When you hit the light to the material, the two photons are coming from the excited state to the ground state. So those two photons are emitted when the electron comes from the higher energy state to the ground state. It emits the two photons, which is called stimulated emission. And these three processes we have already discussed, and we also mentioned that P Einstein coefficient, right? Three equations. Those are really important equations. Okay. So you can add them, some of them join now. So now, I hope you practice those Einstein, those emission, absorption, and stimulated emission. I hope you practiced a lot. I know you didn't practice, but you have to do it. And this is also very, very important: population inversion. What is the meaning of population inversion, beta? What is actually meaning here that we are looking? Inversion means opposite, right? So population inversion, the word itself you have to understand. So usually this is the E1 is the ground state, E2 is the excited state. If E2 is the greater than the E1 in terms of the atoms, we call it population inversion. Like we are making the more atom in the E2 level than the E1 atom. E1 level. E1 is the ground level. E2 is the excited level. I mean higher energy level. If you are making the more atoms present in the higher energy level than the lower energy level, that is called population inversion. I mean you are making it to reverse it. It is the process of increasing the excited electron in higher energy level. Ade cheppanu kada. Ante you are basically increasing the excited electrons in the higher energy level, right? Then the lower energy. Due to this process, the production of laser is possible. You are increasing the laser more. The energy level between the ground state and the excited state is known as metastable state, beta. There is a level, Nana. This is the, I'm going to talk about three level system: E1, E2, and this is E3. And the E3 is the one we call it as a metastable state, beta. Sir, we didn't even understand this. So usually, some of the electrons come from the ground higher energy level to the ground state directly. This is, we already see that spontaneous emission, stimulated emission. And whereas other electrons go from E2 to E3, then E3 to E1. And this is the long process, kind of stimulated emission. You have a one photon from here, one photon from here. That is a stimulated emission. And we call this is a metastable state. What is state? Metastable state. Very important. What is the metastable state? Sir, it is an intermediate state. Oh, really? Great. Thank you so much, Nana. What is E2? It is a higher energy level state, sir. What is E1? Ground state, ground energy level, sir. Very nice. And what is E3? E3 is the intermediate, sir, which is actually some of the electrons take the transition from higher energies level to the E3 level. So which is actually metastable state. Oh, very nice. You guys are really wonderful. By optical pumping, electrons, by optical pumping, electron from the ground state jumps to excited state by absorption process. So we already understand that. So these are the E2, E1, E3. So first, what is the process beta? Absorption process. The photons are absorbed by the material. అంటే అబ్జార్ప్షన్ ప్రాసెస్లో ఆప్టికల్ పంపింగ్ చేస్తున్నాం. వీఆర్ సెండింగ్ ద మోర్ ఆటమ్స్ ఫ్రమ్ ఇయర్ టు ఇయర్. వీఆర్ సెండింగ్ ద ఎలక్ట్రాన్స్ ఫ్రమ్ ఇయర్ టు ఇయర్. వీఆర్ మేకింగ్ E2 is greater than the E1. That is called optical pumping. More excited electrons in the E2 than the E1. అర్థమైందా నాన్న? Did you understand better?
Yes, sir.
ఇప్పుడు పాపులేషన్ ఇన్వర్షన్ అంటే అర్థమైందా? పాపులేషన్ ఇన్వర్షన్ అంటే ఏం చేస్తుంది చెప్పండి? హయ్యర్ ఎనర్జీలో ఎక్కువ ఎక్సైటెడ్ ఎలక్ట్రాన్స్ ఉండేటట్టు చేస్తున్నాము. ఎలా? అబ్జార్ప్షన్ లైట్ ఎక్కువ లైట్ మన మీద పడితే ఏమవుతుంది? బాగా ఫేస్ అంతా బాగా ఎక్సైట్ అయిపోతాం కదా. అలాగే ఫోటో తీసేటప్పుడు ఏం చేస్తారు? ఫ్లాష్ కొడతారు. ఎందుకు బెటా? యూ ఫీల్ లైక్ సో ఎనర్జెటిక్ అన్నట్టు. బాగా ఆ ఫ్లాష్ అంటే ఎనర్జీ ఎక్కువ అవుతుంది అన్నట్టు. మనలో ఉన్నటువంటి అంత ఎలక్ట్రాన్స్ అన్ని కూడా ఎక్సైట్ అయిపోతాయి. ఎక్సైటెడ్ ఎనర్జీ లెవెల్కి వెళ్ళిపోతాయి. రైట్? సో యు ఆర్ మేకింగ్ ద మోర్ ఎక్సైటెడ్ ఎలక్ట్రాన్స్ in the higher energy level than the lower energy level, which is called actually, what is it called? Population inversion. అర్థమైందా? Is it clear beta? Hello?
Yes, sir.
Any doubts? Sushma, Swapna, Gautami, Vani, Shamir?
No, sir.
No doubt, huh? డౌట్ ఉంటే డౌట్ ఉందని చెప్పండి అన్న. ఏం లేదా?
No, sir.
వెరీ నైస్. సో ఆప్టికల్ పంపింగ్ గురించి అర్థమైంది కదా ఇప్పుడు? వెరీ సింపుల్ అన్న. ఇట్ ఈస్ ద రివర్స్ ప్రాసెస్. బేసికలీ యూఆర్ ఇంక్రీజింగ్ ద ఎలక్ట్రాన్స్ ఇన్ ద E2 దెన్ ద E1. ఆ ఇంటర్మీడియట్ ఉన్న స్టేజ్ ఏమంటారంటే మెటాస్టేబుల్ స్టేజ్ అని అంటారు. ఓకే, ఎలా పంపింగ్ చేస్తాం సార్ అంటే అబ్జార్ప్షన్ ఆఫ్ ఫోటాన్స్ తోని అనేది చెప్పి గుర్తుంచుకోవాలి. ఇవన్నీ కూడా బిట్ టైప్ వస్తాయి డైరెక్ట్గా ఎంఎస్సి కాంపిటేటివ్ ఎగ్జామ్లలో. సో నెక్స్ట్ ఇంకేముంటుంది సార్ అంటే వెయిట్. రైట్, ఇక్కడ చూస్తే మీకు so the electrons, basically the electrons, ఇక్కడ క్వశ్చన్ అడుగుతారు బెట, ఇంపార్టెంట్ బిట్ ఉంది కాబట్టి చెప్తున్నాను. The electrons remain only for 10 to the power of, is important, 10 to the power of 10 power minus 8 seconds in the excited stage, which is called metastable state. So most of them jumps back to the ground state E1 by emitting the photons, but some of them directly jump from E2. అందుకే రెండు వస్తాయి అని చెప్పాను కదా. రెండు ఫోటాన్స్ వస్తున్నాయి కదా. ఏ ప్రాసెస్ లో రెండు ఫోటాన్స్ వస్తాయి నాన్న? విచ్ ప్రాసెస్ ద ఫోటాన్స్ కమ్స్ టు? అబ్జార్ప్షన్ ప్రాసెస్. ఎమిషన్స్ రెండు ఉన్నాయి కదా మనకు, స్పాంటేనియస్ ఎమిషన్, Stimulated emission. Which process we get 2 photons out? Anyone can tell?
Stimulated.
Stimulated emission. Very good. Stimulated emission lo we get 2 photons out. ఎక్కడికి వెళ్ళి వస్తున్నాయి అంటే అవి ఒకటేమో డైరెక్ట్లీ ఇక్కడికి వెళ్ళి వస్తుంది బెట, ఏది E2 నుంచి E1కి జంప్ చేసినప్పుడు. ఇంకొకటి ఏమని చెప్తున్నా E3. సో E3 is another stage, another state which you call metastable state. అక్కడ 10 పవర్ మైనస్ నో ఇక్కడ మాత్రం 10 పవర్ మైనస్ 8 ఉంటుంది అన్న. ఇక్కడికి వచ్చేసి 10 పవర్ మైనస్ 3 అంతే టైంలో ఉండి కిందికి వచ్చేస్తాయి. ఇక్కడ నుంచి వచ్చినప్పుడు ఒక ఫోటాన్ వస్తుంది, ఇక్కడికి వెళ్ళి వచ్చినప్పుడు ఒక ఫోటాన్ వస్తుంది. ఓకే, then so now we understand the electron remain only this much time in the E2 in excited state. Actually this is E2 beta. Most of them jumps back to the ground state by emitting the photon. Okay, some of them jump into the metastable state. The electrons stay in metastable time entante inta. ఇదేమో ఎక్సైటెడ్ E2 స్టేజ్ బెటా. E2 స్టేట్లో 10 పవర్ మైనస్ 3, మెటాస్టేబుల్ స్టేట్లో ఇప్పుడు 10 పవర్ మైనస్ 3 గ్రేటరా 10 పవర్ మైనస్ 8 గ్రేటర్ అంటే ఎవరు చెప్తారు చెప్పండి? విచ్ వన్ ఈస్ గ్రేటర్?
10 power minus 3 is
కరెక్ట్, దిస్ ఇస్ గ్రేట్. అంటే ఎక్కువ టైంలో ఎక్కడ ఉంటాయంటే మెటాస్టేబుల్ స్టేట్లోనే మనకు ఎలక్ట్రాన్లు ఉంటాయి. దట్స్ గుడ్, వెరీ నైస్. సో ఇక్కడ the electron density increases in a metastable stage. The transitions are possible. It takes more number of electrons together. Okay, this photon, metastable photon beam is produced, which is constitute laser beam. అంటే మనకు ఇక్కడ E2 నుంచి వస్తాయి, మెటాస్టేబుల్ నుంచి వస్తాయి కాబట్టి మనకు ఈ అంటే ఇది 3 లెవెల్ సిస్టమ్ అంటారు దీన్ని, 3 లెవెల్ సిస్టమ్. So now you understand, I guess. I don't want to mention a lot. I mean, I just want to tell that.
సార్ వాయిస్ వినబడట్లేదు. మ్యూట్ లో ఉంది సార్ మీది.
Okay, so yeah, sorry. Yeah, optical pumping, there are 3 methods unnai beta. Optical pumping, optical discharge, direct conversion, but we don't need this. We just we don't need just only absorption process. We get the optical inversion. So sorry, optical inversion is over, right? Sorry. So what method we completed previous slide? Optical inversion, right? What is this? So optical population inversion is over. Population inversion is over. Yes. Population inversion is over. Now optical pumping. అంటే population inversion అవ్వాలంటే ఏం చేయాలి? So what we have to do? We have to increase the E2 greater than the E1. By the process we call it as a optical pump. So there are few methods to make this possible. How? So when a photon of blue-green light, kind of blue or green light, incident on the ruby crystal, there is a crystal metal. Electrons from the ground state observe, electrons lo ground state lo unnatuvanti electron lo they observe the light and jumps onto the higher energy state level, come back to the metastable state. Okay, come back to the metastable state. They increase the population of electron in the metastable state, and this process is called optical pumping, which is done by the flash tube. So now understood. Now let me repeat again. So optical inversion అనేది మనం చేసాము. So now that this is actually ఆప్టికల్ పంపింగ్ అంటే సో డెఫినెట్గా మనము ఎక్సైటెడ్ స్టేజ్లో మనకు ఎక్సైటెడ్ స్టేటస్లో ఎక్కువ ఎలక్ట్రాన్స్ ఉండాలి దెన్ ద గ్రౌండ్ స్టేట్. how it's possible? We have to use the flash tube. కంప్లీట్లీ లైట్ మీద పడుతూనే ఉండాలి మెటీరియల్ మీద. ఏ మెటీరియల్ మీద? రూబీ క్రిస్టల్ తీసుకోవాలి. రూబీ క్రిస్టల్ తీసుకొని వాట్ వీ హ్యావ్ టు డూ ఈస్ వీ హ్యావ్ టు యూజ్ దిస్ light, green light incident on the ruby crystal. So when you apply this is a ruby crystal, when you apply the light on the ruby crystal, the electrons which are in the ground state, they go for the higher energy levels, E2. Then the electrons go for the E3. So more electrons there in both these E2, E3 than the E1. So E1 is the less than the E2 and E3 together. So this is called population inversion. How it's possible? It is possible only by flash tube technique. Okay, is it clear, students?
Yes, sir.
So we completed the optical pumping population inversion. To get the population inversion, we have to do the optical pumping. Antena population inversion రావాలంటేనే optical pumping చేయాల్సి వస్తుంది. That's it. సో ఇది కూడా లాంగ్ ఆన్సర్ బిడ్డ, మనం కంప్లీట్ చేసాం ఆల్రెడీ. we already completed, but I just want to go through again as a long answer question లాగా చదువుతాం. ఇక్కడ ఇంత ముందుకేమో సపరేట్ గా చదువుకున్నాం. ఇది రిలేషన్ obtain the relation between the Einstein coefficient A and B అంటాడు. దానికి ఏం చేస్తామంటే Einstein obtain a mathematical expression for the existing of two different kind of process. రెండు ఎమిషన్స్ ఉన్నాయి కాబట్టి so consider all atom in the thermal equilibrium at temperature T. Radiation of frequency F, energy UF. N1 N2 are the atoms in E1 and E2 respectively. అంటే E1 state లో ఉన్న atoms N1, E2 states లో N2 atoms are there. In equilibrium process, what happened? These two are same. In equilibrium process, what happened? B12 N1 UF, A21 N2, B21 N2 UF. Sir, what is this, sir? This is you already did absorption also, right? We completed. So this is the final now. B12 N1 UF is equal to, and there are two processes I said, A21 N2 plus B21 N2. Okay, so two emissions are there, right? Stimulated and spontaneous emission. So that should be, both are equal. So absorption must be equal to emission. So from here, what I can do, A21 I want to write it from A21. A21 ఒక సైడ్ తీసుకొస్తే ఎందుకంటే అబ్జార్ప్షన్ కావాలి. A21 is equal, N2 is equal to, ఈ రెండిట్లలో UF కామన్ గా ఉంది కాబట్టి I just took it out కామన్. ఓకే, అప్పుడు దాని నుంచి what I can get it is, I want to get equation from UF, energy equation. సో అప్పుడు ఏమవుతుంది, A21 N2 by this entire thing వస్తుంది. అర్థమవుందా ఇది? Did you understand? నానే ఇది అర్థమైందా? ఇది ఎలా వచ్చిందో కూడా మీకు ఇంత ముందుకు చెప్పాను. I think I hope you understand. Let me go back if you want to see back that one. So B12 అంటే ఏంది బేటా? అబ్జార్ప్షన్, రైట్? అండర్స్టాండ్ అవుతుందా బేటా? ఈక్వేషన్ రాసుకురా. P12 B12 అంటే ఏంటి? ఇది అబ్జార్ప్షన్ కదా.
Absorption.
నోట్ చేసుకోండి ఈక్వేషన్. అబ్జార్ప్షన్ ఈక్వేషన్ వి గాట్ దిస్ వన్, B12 N1 UF, రైట్? Did you note down?
Yes, sir.
Absorption is over. Emission, what we got it is this one emission. స్పాంటేనియస్ ఎమిషన్ ఈక్వేషన్ వచ్చింది A21 N2. A21 N2. This is a spontaneous emission. Then what we got next? Stimulated emission. Stimulated emission, we got it B21 N2 UF. Right? Did you understand? Did you note down?
Yes, sir.
A21 B21 ivemo emissions. So now I am writing here. So now this equation you have to understand. What is this beta? And what is this? And what is this? These two are emissions, right?
Mm,
What is this emission? Tell me.
Spontaneous.
Very good. This is spontaneous. This is stimulated, right?
Yes.
So absorption of the radiation. Inte beta ikkada gurtunchukunte meeku diagram E1 E2 and metastable E3. ఈ డయాగ్రామ్ వేసి మీరు ఎక్స్ప్లెయిన్ చేయాలి. సో ఇదేమో ఇది బెటర్ అబ్జర్ప్షన్ అవుతుంది ఫోటాన్. సో దిస్ ఈజ్ వాట్ B12 and then you have the A21 and you have the B21. Okay, so now tell me. So absorption must be equal to sum of the emission, right? Is it clear? అంటే ఎంత అయితే అబ్జార్ప్షన్ ఉందో అంతే ఎమిషన్ అవ్వాలనా వద్దా?
Yes, sir.
So the total absorption of light observed by the material must be equal to the total emission of the light emitted by the material. మెటీరియల్ ఎంత అయితే ఎమిట్ చేసిందో అంతే అబ్జర్వ్ చేసుకుందని ఈక్వలిబ్రియం దగ్గర సమానం కావాలి. So from here what I want to write equation for UF ki equation కావాలి. So for that what I have to write? I have to write A21 N2 which is equal to B12 N1 minus B21 N2 into UF. This is the energy. But I want to get equation for UF better. ఏమైతుంది? A21 N2 by B12 N1 minus B21 N2. Is it clear this equation? All of you? Long answer. Is it clear, Nana?
Yes, sir.
Yes, sir.
Equation 1 is clear. That's good. Then what I am doing here? So what I am doing here, you have to understand. What I did it is here from this equation and this equation, what is there is I want to divide by B21 N1. So B21 N2 B21 N2. Divide that equation by what we have actually UF equal to. Actually we have this one A21 N2 by right B12 N1 minus B21 N2. So now what I am doing is I am dividing this equation with N2 B21. So whatever is here, I am dividing both equations. Numerator ni denominator ni divide chestunna. Divide cheste emaithundi beta ikkada N2 ikkada N2 untadi kabatti it's cancel. Ikkada B21 N2 kabatti idi cancel ayipothe 1 vachindi. Ikkada B21 N2. So we got this equation. Is it clear?
Yes, sir.
So this equation also clear. We call it as equation number 2. Then Boltzmann distribution law em cheptundante N1 anedi the number of atoms present in the E1 state is equal to this ground state lo unnani. The number of atoms present in the ground state N1 is equal to N0 e power minus E1 by KT. This is Boltzmann law. Thermodynamics చదువుకుని ఉంటారు. And N2 is equal to N0 e power minus E2 by KT. When I divide this N1 by N2, when I divide by N1 by N2, ఏమొస్తుంది పెట్టి ఇక్కడ N1 by N2 చేస్తే ఏమొస్తుంది? N0 క్యాన్సిల్ అయిపోతుంది. ఈ పైన మనకి ఏమొస్తుందంటే E2 minus E1 by KT. Can we get this equation from here? Do you understand how we got this one? Student, my dear student.
Yes, sir.
How we got this one, you understand, right?
Yes, sir.
Just need to make this minus this. So E2 become plus అవుతుంది. So E2 minus E1 by KT అవుతుంది. So E2 minus E1 అంటే మనకి ఏమొచ్చింది ఎమిషన్ లో? Hnu అంటాం కదా, Hnu గాని HF గాని రాస్తాం. Because the difference of this energy level gives the photon energy. Photon is HF గాని nu అంటే frequency beta. It could be F or it could be nu. So దీన్ని సబ్స్టిట్యూట్ చేస్తాము. అప్పుడేమొస్తుంది? EHnu by KT వచ్చింది. EHnu by KT. Did you copy?
Yes, sir.
Yes, sir.
Yeah. So you can get this equation. E2 minus E1 equals 5. N1 by N2 equal to HF by KT. This equation we got it. So let me clear all this stuff. So now Einstein equation also long answer question beta. So now we substituted that. UF we already got this before. Okay. Then what we do here is you have to substitute this. N1 by, before it was there, what is there beta? N2 by, wherever you have this N1 by N2 దగ్గర ఏం రాస్తున్నాం అంటే ఈ ఈక్వేషన్ రాస్తున్నాం బెట. ఇక్కడ ఎక్కడైతే N1 by N2 ఉందో we are writing e power HF by KT. Okay, is it clear?
Yes, sir.
Yes, sir.
Very good, very good. Sorry, I know you have a class. I think you may have Trimalets class in the.
Yes, sir. 10.
Yes, sir. 10.
It's still time there, right? What's the time now?
9:56.
9:57.
Okay, we have still. I can ask him to take 10 minutes late, maybe. Right. So I just substituted beta here. I just substituted that N1 by N2 is HF by KT. So this is actually original equation that we got it before. So after that, according to Planck's, this is also you thermodynamics, you would have studied this one. I don't want to, you just need to remember this. This is the equation from, we got it from thermodynamics. Let us say 8th equation. And compare here. And you can keep here B12 equal to B21. B12 equal to B21. What are the B1 and B2? Tell me. B1 is what? B12 is what?
Absorption B12. Absorption is equal to stimulated emission.
Oh, right. Very good. So absorption equals stimulated emission. They are saying this is assumption they want to make it according to Planck. He did. And also A21 by B21. So he is keeping this value better. This is the, according to Planck's equation, he just substituting that. What he is doing is B12 equal B21, we are keeping equal. So this is cancelled. Okay. And A21 by B21 is keeping this is equal to this. So now we get this equation. So we got, so to compare Planck, we are almost there. So from this optics also we were able to produce this. అంటే ఈ కాన్స్టెంట్ వాల్యూ ఇది అవుతుంది, ఈ రెండు సమానం అయితే మనకు ప్లాంక్ డిస్ట్రిబ్యూషన్ వచ్చేసింది. సో ఫైనల్లీ the ratio of spontaneous to the stimulated emission is this much. Spontaneous ki stimulated division చేయగలిగితే మనకి ఇది వస్తుంది. So this is what easy, but you just need to practice better. Very easy actually, long answer. You just need to practice it. So over, this long answer is over. Finally, just whatever we got it here, just now say this one. I mean, we according to Planck, we verified with the Planck, we were able to this, and this is the R value. Ratio of the R is what? Ratio of the stimulated to the spontaneous. Is it spontaneous to stimulated or stimulated to spontaneous? What we got it before? R value. R value is it is the ratio of the spontaneous to the stimulated. So R is actually what? Spontaneous to the stimulated. So finally, so this is, you can write down, this is stimulated. When this condition is applied, stimulated emission. Okay. And when this is applied, these are the important bit for the competitive exams. Condition for the spontaneous emission. Frequency should be more than the thermal energy. If the thermal energy is more than the applied energy, stimulated means you are applying external energy, thermal energy. Then only you get the stimulated. Why KT is greater than the H nu? Because you are applying thermal energy to get the stimulated. So this is the HF is normal than the thermal energy, which is normal emission, which is spontaneous. So thank you guys. I think it's clear, this derivation. Then I think I think this essay question is over. Ruby, there are one more class, I guess we need it, but I try to maybe I can go quickly Ruby laser. So one more, I mean, we have two more long answer questions. One is Ruby laser and the other one is helium neon laser. These are the two long answers. Second essay, third essay. We have three long answers. Out of three, we will get one. Okay. So what is Ruby laser? What is the helium neon laser? We have to discuss now. Only two questions are there. So I guess, tell me, can I begin, or do you want this to be the new year?
New Year, sir.
You want a new year?
Yes, sir.
So yeah, I can do it. Two more classes. Hardly we need two more classes. Ruby laser require one more class, and helium neon laser need one more class. That's it. So just long answer. You have to need some 10 points. This is a diagram, you need it, and then go further applications. This is a helium neon laser. Really a lot of applications. Construction over. So this is the diagram. That's it. I think a couple of slides are there. Over. So hardly I can try to finish one class, maybe. Then maybe summary, one more class. So in the new year, we're going to complete the 2nd of January. I'll try to finish this, and then the 3rd and 4th, I'll try to go for the lab. Okay? Any doubts, Nana? Today class?